exterior lighting, hobby use of, who knows what. And also within the house, things like, the guy's running his business out of his house and he has a server and 3 computers, or a kid that plays video games 12 hours a day, or a reef fish tank that can use an amazing amount of energy. We go through and we try to calculate exactly how many kilowatts is required for any possible use, and then design the solar system to produce that amount. It's a little extra work, and it's not standard. If you look at the energy code as the model, they only care about what happens inside the walls of the conditioned space. They don't care what you do on the outside. And we've done snowmelt systems for people that use 20 times more energy than the house will use. And we went through that thought, but with the way electric rates are in California, we wanted to make sure that we were doing the complete job. And not only the way electric rates are, but the fact that PV's gotten so cheap that it makes sense to go ahead and just do it completely accurately from the beginning. Okay, then we have a scorecard. And the scorecard takes into account, right off the energy calcs, we're able to calculate how many kilowatt hours are required for space heating, cooling loads, and domestic hot water. Although the domestic hot water, we get some input from the owners. And then from our worksheets, we're able to look at how many kilowatt hours are required for, off the lighting appliances in our standard, indoor loads. And then we factor in any extra use, be it a well pump or whatever else, and we come to a total of how many kilowatt hours are required or going to be required for this house. And then we just design and size a solar electric system to produce that many kilowatt hours. The great thing is in the solar electric systems is there's a lot of things that are known. The units have to come with a 20-year warranty. They have to be verified by a third-party HERS inspector to make sure they're producing as much as they're supposed to. There's a lot of kind of security built into these systems that makes it easier for us. Okay, so the program we're talking about, Net Zero Energy Certified, and the goal is to promote, consult, specify, quantify, and verify net zero energy homes and buildings. We have several school projects we're working on also. It is our belief that this is a low-cost, simple, and very obtainable process, and something you can offer to your clients. And this is a green building program that is 100% energy. We don't care how big it is. We don't care. I mean, there's just it could be any style. All we do is we calculate how many kilowatt hours are required, and then size and design a PV system to produce it. And we've done 100 projects, and no two are anything alike. The numbers come out great. Anyway, our goal is to be considered equivalent to LEED or Build It Green. So in communities that require this sort of a green building certification program, our goal, which we're not there yet, is to say, yeah, well, you could build it to LEED standard, you could build it to Build It Green, or you could just do a Net Zero Energy Certified. That's our goal going up, and that's our goal for 010. All right, so we've talked about a little bit how we calculate how many kilowatt hours required. Let's go through our options on producing that amount of energy. You have 3 basic choices. You got solar thermal, you got solar electric, and what's known as PVT, which is a combination. Quick solar basics. One of the things you need to understand, and most everybody does, most of the energy that falls on your roof falls on it spring, summer, and fall, with much less being, in the winter time. That's the first basic thing you need to understand. The second basic thing is the sun angles. In the wintertime, the sun is very low in the sky, peaks at about 30 degrees above the horizon. We just had the solstice a couple weeks ago. And at noon on the December 21st, the sun's about 30 degrees above the horizon. In the summertime, it's just the opposite. In the summer solstice, the sun is, 76, 77 degrees above the horizon. And there's much less shading going on. So my point is when we can collect the energy in the summertime, there's not only a lot more of it, but you have a lot less problem with shading. Solar thermal systems, and like I said, we've been designing them and overseeing their installation for 5 decades now. And for the most part, it's always been difficult. especially for space heating. For domestic hot water, it can work out very well, especially for things like laundromats and swimming pools where there's kind of a consistent use. But for space heating, it's always been a nightmare, and it'll always be a nightmare. Some of the problems with space heating is because the sun is low in the sky in the winter, as I just showed, you have to tilt the panels up very steeply to collect the low winter sun. And having panels be tilted at 45 degrees is hard to integrate in the building. Usually within 2 or 3 days, you have to not only collect the energy, you have to store it, and then you have to use it. Otherwise, it's lost. Third thing is that when you're trying to heat the house in the wintertime is not the time when you have abundant sunshine. You have abundant sunshine in the spring, summer, and fall when you don't need the space heating. So you're always just kind of fighting the way the way the flow works. The systems can be very complicated and very expensive. Again, cost-effective for swimming pools and laundromats. The other thing I didn't say here is that systems are not without their maintenance. And they're very difficult for homes that are for part-time homes. Maintenance-wise, you're always worried about freezing. You're always worried about the system steaming over in the summertime because you have all these panels sized to do the space heating in the wintertime with not much to do in the summer. Anyway, solar thermal systems are difficult. The last system we installed, it looks like this. The big white thing in the middle is a storage tank. It's about a 600-gallon storage tank. And this house is complicated. This is doing a swimming pool. It's doing space heating, and it's doing domestic hot water. But again, very complicated and expensive. Now, you compare that to grid-tie solar electric systems. Everything you see here is basically replaced here and here. And additional advantages are the panels can be now mounted low or flat to the roof because in the summertime when the sun's high in the sky, we can have the panels mounted on a typical 4 and 12 roof or even flat on the roof. We do a lot of systems where the panels are mounted flat, completely invisible from the street, and we just rely on collecting enough energy in the summertime that will bank that energy and then use it on the wintertime. I should explain how grid-tie solar electric systems work. You get 1 meter. You get one bill. You're billed over the course of a year. And so if your system turns on in January and your panels are mounted relatively flat and we're not collecting too much energy, plus we're using a lot because the days are longer and it's colder, we're going to go negative. And we're going to owe PG&E or whatever the utility is lots of money. But we don't owe them yet. We just, in the summertime, or in the spring and summer, the sun's higher in the sky, we start collecting more, we start using less because the days are shorter and they're warmer. Next thing you know is our meter's running more towards the middle or maybe even positive. Same thing in the fall. Wintertime comes around, maybe we're positive, but now we start to go negative again. If we've all done our job right, if it's a nice, efficient house, we've reduced as much as we can and we've sized it properly and we're producing the right amount, by the time the year rolls around, our meter should read 0. That's how the systems work. It's very important to understand the way any energy we collect any time the year is utilized. One of the problems with solar thermal systems is you have all these panels made, solar thermal space heating systems, you have all these panels made to do space heating, but for 7, 8 months a year there's nothing for them to do. And it makes it so, there's just a lot of problems you can get into it. With a grid-tie solar electric system, any energy we collect any day of the year is utilized fully. There's also no transmission losses. If you look at your utility bill, about 20% of the costs are transmission losses. And the best part of all, or one of the very best parts, is there's little or no maintenance with these systems. 10, 12 years ago, this inverter here, people had a little trouble with, but those have gotten a lot better now, and the panels